Let's read this problem all together. A 6-lane urban freeway with 3 lanes in each direction is on a rolling terrain with 3.3-meter lanes, obstructions 0.6 meter from the right edge of the traveled pavement, and 9 ramps within 5 kilometers upstream and 5 kilometers downstream of the midpoint of the analysis segment. The traffic stream consists primarily of commuters. A directional weekday peak hour volume of 2,300 vehicles is observed, with 700 vehicles arriving in the most congested 15-minute period. If the traffic stream has 15% large trucks and buses and no recreational vehicles, determine the level of service. So in this sample problem, we are going to determine the level of service of the freeway with base conditions that are mentioned here. So the given information in the problem is also the base conditions that you can use for solving the problem. So let's see. The given information we have include the lane width, which is equal to 3.3 meters. There are 3 lanes in each direction, and it was mentioned that we have a rolling terrain. And the right lateral clearance is equal to 0.6 meter. The total ramp density, it was mentioned in the problem that there are 9 ramps for 5 kilometer upstream and 5 kilometer downstream. So it means that you have 9 over the total length, which is equal to 0.9. And then, since it was mentioned that the vehicle users are primarily commuters, so we can use the driver population factor of 1.0. And then we have a total vehicle per hour of 2,300 vehicles per hour. And then the most congested 15 minutes has 700 vehicles per hour. It was also mentioned in the problem that the percentage of truck is 15%, and then there are no recreational vehicles, so PR is equal to 0. So next slides will show us how to determine the LOS following the 4 steps that we have discussed in the previous slides. So since the first step entails the basic information that we have for the freeway, then we have already completed that step. So we will move now to determining the free flow speed of the freeway. From the previous discussion, the formula for determining the FFS is equal to this one. So what we need is to identify the factor for the lane width adjustment, the factor for the lateral clearance adjustment, and anyway, we are given the TRD, so we just substitute the other information here. So actually, the FFS, if we have known already the FLW and FLC, and the TRD, which is 0.9, then we can calculate the FFS is equal to 109 kilometers per hour. Now, how did we find 3.1 and 2.6 here? I will show you in the next slides. So for the lane width adjustment factor of FLW, since we have the lane width, which is equal to 3.3 meters, then from this table 7.2, we can know that the reduction in free flow speed is equal to 3.1 kilometers per hour. And for the lateral clearance adjustment factor, we used this table 7.3. So what information do we need here? We needed the right shoulder lateral clearance, which was given in the problem, and it is 0.6. And here we also know from the problem that we have 3 lanes in each direction. So with this information, we get to know the FLC, which is 2.6 kilometers per hour. Okay, so we move to the next step, the step number 3, to calculate the analysis flow rate using the formula that we have discussed earlier, which is the total volume in an hour divided by the product of the peak hour factor times the number of lanes per direction times the heavy vehicle adjustment factor times the driver population factor, FP. So in this problem, what we need to calculate first is the peak hour factor and the FHV. I will show you how FHV is equal to 0.81816 was calculated, and also for the value of PHF. How did we derive PHF of 0.821 here? Okay, but first I would like to show you how to calculate the flow rate using this formula. So using this formula, just substituting the values, we have V is equal to 2,300, and then we divide it with the product of PHF, which is 0.821, and then times the number of lanes, 3 times this, and then 1.04, the driver population factor. Now the flow rate that has been calculated is equal to 1,140 passenger car per hour per lane. So in the next slides, I will show you how this was calculated and how the heavy vehicle factor was calculated. In determining the peak hour factor, we have to divide the total volume in 1 hour by the 15-minute most congested times 4. So that becomes 2,300 divided by the given vehicles in the 15-minute most congested time, which is 700 times 4. So the peak hour factor is equal to this one. Now this slide shows you how the heavy vehicle adjustment factor was calculated. So using this formula that we have also seen in the past slides, this is the percentage of trucks and buses, which was given in the problem, that's 15%, and the PR percentage of recreational vehicles is 0. So actually this term is already 0. But anyway, in the next slide, I will show you how ET and ER here is found. So substituting the PT and the ET, which is found using the table, which I'll show you in the next slide, the heavy vehicle factor then becomes 1 over 1 plus the product of this. So it's equal to 0.816 here. Okay, now how did we arrive with the 2.5 ET? I'll show you in the next slide here. Using the table 7.4, when we were mentioned that we have a rolling terrain, so we will use this column, and we need ET, so ET corresponding with the rolling terrain is equal to 2.5. And then next is we calculate the density which we will need in finally determining the level of service of the freeway. So using this formula, density is equal to the flow rate over the average speed. Since we have calculated the flow rate, which is equal to 1,140, now our next concern is what is S, average speed. So this is based from the free flow speed that we have calculated in our second step. So in that step, we found that the FFS is equal to 109 kilometers per hour. So based from this, we need to look at the table or the chart, which I will show you in the next slide. So let me just move on to this chart first. Okay, so we have 109 kilometers per hour. These are actually the S values that we're going to use. And if we look at 109 kilometers per hour, it's not actually here. And it is between these two, 104.6 kilometers per hour and 112.6 kilometers per hour. So what we can do is, we should use the value, the speed here between the two that is lower than the actual FFS calculated. So we can use 104.6 for our S. So therefore, our density becomes 10.9. So with this information, we can now determine the level of service of the freeway. So you can either use this chart, which I have presented earlier. So since the calculated density of 10.9 is actually in this part, it's between 6.8 and 11.2, then the level of service of the freeway is within the region of LOSB. Okay, and then you can also use this table to determine the level of service. Since we already have calculated the density, which is equal to 10.9, and it falls within the range of between 6.8 and 11.2, then we have the level of service of freeways B, which is consistent when you use the chart we have seen earlier. Okay, so that answers the question that we have to answer in the sample problem. Okay, so this ends the section, our lecture on the section of determining the level of service for freeway. And these are the references that I have used in these lecture slides.